Okay, hi calculus students. I'm sorry I'm gone today. Something I need to be at, so you need to have these notes in front of you. Um, the handout should be available, and obviously if you need to rewatch a video, um, I can upload this online. We are just going to do a small section today on Unit 4.8, and that is really applications to economics. Okay, and so that's what we're going to focus on. And I would hope that if you struggle with this, you can watch it, or you can look through your book, talk to each other for help. We're going to divide this up into 2 days, and we touched on this briefly back in chapter 3. As we look at it now, we're just going to define some of these pieces. If you remember, the cost function we just defined as C of x, and the average cost, well, if it cost me $100 to make 5 items, it would be $20 an item. You take whatever the cost is and you divide it by the number of items. It's produced X items, and that's going to be average cost. The marginal cost we said was the cost of producing the next item. So cost of producing the next item. And the way we define that is that's basically your instantaneous rate of change at that given point. So it's C prime of x, or the derivative of the cost function. So what we want to do is we want to minimize, I would say, average cost. That's what we're going to focus on today. The other sections we won't fill in, but and you'll get these notes on the test as well so that you can know exactly what you're doing. But you want to minimize the average cost. And so what we're going to do for example 1 is we're going to show how you actually generate um, the minimal average cost. I know you guys would agree. Yesterday we were making gutters. Suppose it costs us, $10 to make the first gutter, 9 to make the second, 8 to make the third, 7 to make the fourth, so on and so forth down the line. You'd like to know at what point we kind of bottom out where it's like, oh, hey, it only costs us $3 to make a gutter. That would be a good point to kind of pause and say, okay, $3. To make 26 gutters, $3 a piece. So that would be a good point to run our efficient business. And so if we want to minimize the average cost function, we'll say A of x is equal to C of x over x. We've already identified that. We're just naming it average cost function is A of x. So I've just used this piece right here, average cost function, C of x over x. Okay? And if you want to minimize means we take the, yes, very good, derivative. You take the derivative and you set it equal to, very good, 0. So what we need to do is we need to take the derivative of both sides. Derivative of A of x is A prime of x equals. And when you take the derivative of C of x over x, you need to use the, yes, quotient rule. Very good. Quotient rule, quotient rule, quotient rule. Quotient rule says you take the derivative of the top, C prime of x, times the bottom left alone, which is just x, minus the derivative of the bottom, which is 1, times the top left alone, C of x. And you take that and you set it equal to 0 if you want to minimize the average cost. So I have x C prime of x then. I put the x in front, just, looks better, minus C of x. And now I'm going to do something kind of strange here, okay? Hopefully this makes sense to you. But there's a nice relationship that exists here. If I add that C of x over to the other side, I get C of x is equal to x times C prime of x. And now when I divide x, I get C of x over x is equal to C prime of x. I'm going to give you a second to write that down. Basically, all we did is we wrote an expression that tells us how to minimize the average cost to run the most efficient business. And what we came up with is an expression that says whenever C of x over x is equal to C prime of x, we know that we have minimized our average cost. And if you look here, what that means is C of x over x, that's just your average cost function. So when the average cost function is equal to, and C prime of x is the marginal cost function. When those two are equal, we have minimized the average cost. And so we've used calculus in order to generate an expression that works very, very well for us in economics. So let's flip it over and let's try a problem. If the cost of producing X items is C of X equals this guy, find the cost of producing 1,000 items. So now we're just going to make sure that you can use the correct formulas. Let me bring up my calculator here. It didn't pop up earlier. Let me see if it does now. Otherwise, I'm going to have to pause this video. Come on, go, gadget. 3, 2, 1. No, you're really not going to come up. Okay, let me pause it. Okay, I got a calculator. All right, so let's do this. Sorry, I'm flustered. I'm trying to get home. Gotta feed the kids. All right, cost of producing 1,000 items. So we're going to plug in 1,000. So basically, the cost of producing 1,000 items is equal to 2,600 plus 2 times 1,000 plus 0.001 times 1,000 squared. And we can just type that in our calculator. Doing ellipses yesterday. 2,600 plus 2 times 1,000 plus 0.001 times 1,000 squared. We'll get 5,600. Okay. Cost of producing 1,000 items is $5,600. B, the average cost. Average cost is C of x divided by x. The average cost for producing 1,000 items. Well, we know the cost. The cost is equal to 5,600. And we know the number of items. The number of items is 1,000. So the average cost of producing 1,000 items is going to be $5.60. So neither of these are difficult. A or B, you guys got this. This is a piece of cake, upside down. C, marginal cost. Do you remember what marginal cost is? Marginal cost is producing the cost of producing the next item, the cost of producing the next item. And the way that we generate an expression for that, that's next item is another way of saying the instantaneous rate of change at that given point, which is another way of saying the derivative. So the marginal cost is C prime of x is equal to, so I'm going to take the derivative of that cost function, derivative of 2,600 is 0. Derivative of 2x is 2 plus, and the derivative of 0.001 x squared is 0.002 x. And you want to know C prime of 1,000, which is equal to 2 plus 0.002 times 1,000. So that's 2 thousandths times 1,000, which is 2. If you don't believe me, try it on your calculator. 2 plus 0.002 times 1,000. And if you do that, you just get 4. So 2 plus 2 is 4. So cost of producing the 1,000th item is $4. Now that makes sense. I mean, it costs probably a decent amount of money to produce the first few items. You're not very efficient then. But by the time you get 1,000, you're maybe down to $4 an item. Okay? Average cost overall, that was $5.60. So now we get to the main question, the production level that will minimize the average cost. We said in order to minimize the average cost, the marginal cost function. So if we go back to this other side. Okay, again, minimize the average cost. That's when C prime of x is equal to C of x over x. That's the thing we just generated down there. We just did that right at the beginning of class. We generated that formula. So we want to use that. So C prime of x equals C of x over x. Let's do it. C prime of x is 2 plus 0.002x equals, our cost function was 2600 plus 2x plus 0.001x squared all over x. So we want to find out when those two are equal to each other. We got to solve. How are you going to solve? Very good. You're going to cross multiply. When I cross multiply, I get 2x plus 0.002x squared is equal to 2600 plus 2x plus 0.001 and then cost. Minimize the errors. Make your production most efficient. Okay, your assignment is 4.8, page 293, numbers 5 through 7. You could probably get those done in class. Not that bad at all. Okay. You're going to do great. Good luck. Can't wait to see you guys Friday. Take care. Bye.